Hi again, back to exponential and log functions. So here, they want me to find the inverse of this function right here. Now, to find the inverse, we always need to change x to y and y to x and then solve it again for y. So to be able to do this, I'm just gonna rewrite this. So the answer to question 1, it's x equals 3 to the y plus 2 minus 1. I'm going to move the -1 to the other side. So x plus 1 equals 3 to the y plus 2. Now I'm going to go to the first rule of logs on how to change from logs to exponential or exponential to logs. So basically, I have exponential functions, so I'm going to go from here to there. Now, if you want to define your variables here, a is the base here, so it's the 3, and n is the exponent, and the exponent is y plus 2, and m is this, so m is x plus 1. So now I'm just going to write this in form of log. I have to have the y come down. I cannot have it as an exponent, and the only way to do this is to change it from exponential to log, and then the y plus 2 will drop. So basically log base a, which is a here is 3, of m, which is x plus 1, equals n, which is y plus 2. And I'm going to solve this for y now. So I'm just going to move 2 to the other side and change it to minus. So log base 3, x plus 1 minus 2 equals y. And therefore, f to the -1 of x, that's how we express the inverse, equals log base 3, x plus 1 minus 2. And that's the answer for part 1. Now, part 2, they want me to find the x-intercept and the y-intercept for this function and then the inverse. So what you need to do here, just find the x and the y-intercept for the exponential function. And then the inverse, what happens, the x-intercept of the exponential function becomes the y-intercept of the inverse. The y-intercept of the exponential becomes the x-intercept of the log. So let's just work on finding the x and the y-intercept here. So to find the y-intercept, always when we're finding the y-intercept, we just equate x to 0 or make x 0. So we have y equals 3 to the power of 0 plus 2 minus 1, which gives me 3 squared is 9 minus 1 is 8. So that's my y-intercept. And so if you want to put it as a coordinate, it'll be 0 and 8. Now, the x-intercept, you make the y 0, and you solve for x. So now what I'm going to do, I'm going to move the -1 to the other side. So I have 1 equals 3 to the x plus 2. And at this stage, to bring the x plus 2 down, you have to log both sides. So basically log 1 equals x plus 2 log 3, because when I log this here, the x plus 2 will drop. Now I'll divide everything by log 3. And what I get this cancels. Log 1 is 0. 0 divided by log 3, 0 divided by anything is just going to give you 0. So 0 equals x plus 2. And therefore, my x-intercept will be -2. So for the inverse, I'm just going to write this here. the x-intercept equals 8, and the y-intercept equals -2. So with this question here, they want you to find the inverse of a log function. So to find the inverse, again, always what we want to do is change x to y and y to x. That's the first thing you always do when you're finding the inverse of anything. So therefore, this becomes x equals log base 2 y minus 1 plus 3. Now I'm going to move the 3 to the other side. So x minus 3 equals log base 2 y minus 1. And if you remember, the log base a m equals n could be changed into m equals a to the power of n. So that's what we do when we're going from log function to exponential function to be able to isolate the y, because right now I'm logging all of this. I need to get rid of the log to solve for y. So therefore, y minus 1 would equal 2 to the power of x minus 3, because the 2 here is the a, and the y minus 1 is the m, what you're logging. So it just becomes y minus 1 is that what you're solving for. And the n is the x minus 3. And so this becomes the exponent. And then you just move the 1 to the other side. And therefore, this is your inverse. And it's always good to write it as f to the -1 of x equals 2 to the x minus 3 plus 1. And that's the inverse of that function. As always, math is like a puzzle, and puzzles are fun to solve. Thank you for watching.